Hello and welcome to another PolyWorks video. My name is Keith from 3D Scanners, and today we're here at the MTC where they've kindly lent us their Renishaw Agility CMM attached to a REVO-2 head, where today I'm going to show you in PolyWorks how we can write a basic inspection program using the I++ CMM plugin connected to Renishaw's UCC server, and how we can get the most out of the REVO-2 head. So we already have PolyWorks Inspector up and running. I am already connected to our I++ CMM connection, and we already have the UCC server up and running in the background as well. With that, we can then go ahead and start by bringing in our CAD model. So if I import our 3D Scanners demo piece. Now, if you're not familiar with the Revo head, it doesn't often like measuring features at an A0, B0 orientation. Hence why, if you notice, our part is actually now sat at an angle. I know it's actually sat at about a 30-degree angle, but if you didn't, obviously what you could do is just quickly manually measure a plane on the surface, measure that against the Z axis, and you can see what kind of angle you have between the two. In this case, we've got a 30-degree angle. So the reason why we do this is to help us with the one-point pre-alignment. If you already didn't already know, the CMM pre-alignment works by probing one single point, but what I'll do is translate the model to the machine coordinate system in X, Y, and Z. It doesn't actually apply any rotation, so we can't really compensate for this 30 degrees that we have in here. A good way to get around that would be to create an additional coordinate system where we can use the method of from translation rotation, and we can rotate the part by, in this case, minus 30 degrees along the X-axis. So now when I view it from the front, you can see that our orientation there matches our part. So let's go ahead and now perform our one-point pre-alignment. So let's start recording our sequence. Let's jump into our alignment, and we can do a CMM pre-alignment. So here we want our part to be pointing in the same orientation as our coordinate system. So the part's coordinate system, we want the Y to be pointing in the Z, which we've got here. So the device's Z is our plus Y, while our machine's plus X is our minus Z. So you can see this lines up with the front of our machine there. The first point I'm going to probe is a point in the corner there. If I wasn't happy with that position, I could always repick this somewhere else, find a more suitable, convenient location to probe. We can use this point, what I've already predefined. And then I can probe point and use the jog box to actually drive my point and take the point. Okay. Now you can see that we are pre-aligned. Before we continue, I'm going to actually go ahead and start planning ahead a little bit and actually start to create some of the geometry and features that we wish to measure. So let's go to our Home tab, and let's start by creating some features. So let's start by creating maybe our bottom plane, which I'll expand to the other side. Let's create this side plane, top plane, plane on top of the slot, and this end plane here. Besides those, we'll also create some cylinders on the ends. I'll create a couple of cylinders on the inside of these holes here, and also some circles just to vary up and give you some kind of, we'll apply some variation to how we measure these. I'll show you some of the additional techniques that are available to the Revo head. Couple of circles. Besides that, let's also add some comparison points. So I'm just going to dot some comparison points on this top surface. And then I'm going to go ahead and just tell PolyWorks that we're going to CNC probe everything. So highlight all your features in your tree, go to properties, change the measurement method to CNC probe. Same with our comparison points. Set that to CNC probe. While I'm in here, these comparison points are all on the same level, and by default they have a 20 mil before and after clearance. We don't actually need those because there's no obstructions, so we don't need the probe to travel that far back every time, so I can turn those off. So now that we told PolyWorks what it is we want to measure, we can now go ahead and tell PolyWorks how we're going to measure. So even though we're using the REVO, and the REVO has the ability to do head touches, whether it's a 3 or 5 axis head touch, you do need to still tell PolyWorks how many points, where you want those points to be, and so forth. After that, we can then tweak it to include the ability to do the 5 axis or even the 3 axis head touch. So we start with our first plane. Our first plane, we can probe 4 points. So just like we did, just like we would with a standard CMM connection, we would tell PolyWorks how many points, clearance, orientation, boundary exclusion values, and so forth. And obviously, if you're not happy with the position of those points, there's nothing stopping us from customizing those points and actually moving them around to exactly where we need. For example, here, I'm going to move this point down to this corner and then the point 2 to the top, so we can probe more in a circular fashion rather than zigzag fashion. I also want to move this point 3 further away from the vertical face. And obviously when it travels between the second point and third point, we're going to have collision through the part. So what we'll have to do there is we'll have to pick go-to position and interrupt that. And we'll interrupt that one on the other side as well. Now, something worth noting is when you're using the REVO, if you're only measuring using the standard 3-axis probe, you still have full access to the collision detection tool within PolyWorks. However, as soon as you start performing any of the more fancy movements from the REVO, whether it's sweeping paths, 5-axis or 3-axis head touch movements, those are running macros in the background, so none of those will actually gain any kind of collision detection warning capability. So you will have to be the collision detection yourself and make sure that there's no collisions. In a future release of PolyWorks, hopefully we'll gain that ability back by once PolyWorks is able to integrate these 5-axis and 3-axis head touches into the software natively without having to run a macro. Once we step away from using the macros, we should hopefully get those benefits back again. So we have our plane set up. Plane 2 is this side plane. I'm happy to just probe 4 points for that plane. And I might increase the boundary exclusion slightly just to avoid bottoming out. We have a larger plane, but the problem with this plane is that there are obstructions. There's a rectangular area and a slotted area that protrudes out, as well as the cylindrical area in the middle. So let's probe 7 points in this case. And I'm going to customize these points by dragging and drop them where I want them to probe. So apply those changes. We'll go from point 1, point 2 in the corner, go across to point 3, down to point 4, we'll hop over to point 5, over to point 6, and then finish off with point 7 in the corner. And again, there's going to be obstructions, so what we'll have to do is we'll add in our go-to positions part way through. So we'll interrupt this line here by moving it away from the surface. We'll interrupt the area between points 5 and 6. So we'll hop over the cylindrical protrusion there. And the same with our slotted area, we'll avoid that by traveling further out. That's all set up. Close. Plane 4 is the plane on top of the slot. I'm happy to stick with the 3 points in there. If I go to my next feature, we have our larger plane on the end there. So there, I'll maybe increase that to say 8 points across that face. We have cylinders that need measuring. I'll do the first 4 first, which are the ones on the protruding exterior cylinders. So those, as you can see there, because they're partial cylinders, they're not a complete full 360 cylinder. PolyWorks knows to then adjust the angular range and the starting angles to maintain the points within that area. So I'm happy with those. We can leave those as they are. We have 2 cylinders on this end. Rather than just probe them in the standard way, what I'll do is we'll tactile scan them. So I'm going to highlight 2 of those, go to properties, and with that set to CNC CMM, we'll actually turn on the tactile scanning option. And rather than doing 2 circles, we'll scan 3 circles through the cylinder. And we'll maybe even apply a max depth so it doesn't go too deep and end up bottoming out on the inner surface there. Happy with that? Apply, close. I'll vary this up again. So rather than just the standard tactile scan where we'll tactile scan 3 separate circles, what we can also do is, specifically to the REVO head, we can apply a helical tactile scan if we wanted to. However, this isn't built into PolyWorks by default. You will have to download what we call the Advanced CMM macro toolbar, which is available on the My PolyWorks portal. Same place where you can download any new version of PolyWorks, there is a macro zone where you can download this macro toolbar. And as you can see, we have the ability to tactile scan polylines, surfaces, spheres, and we can do here a helical scan. So with a helical scan, all we need to do is specify the helical pitch. So we'll say a 3 mil pitch. We'll take a point every point-to-point spacing of 1 mil, so a point every 1 mil. And we can specify an angle, or we can let PolyWorks figure that out for us. And at which point, hopefully it'll stay in the center and just sweep outwards. But if you ever want to maintain an angle, a fixed angle as it sweeps around, you can always set that to custom and then type in a custom value angle. For 2 of our circles, we'll tactile scan these 2. So right-click properties. What we'll do is we'll tick on the tactile scanning option. And what we probably want to do is we want to use an existing plane to help constrain to. If you're running the REVO head with the 5-axis capabilities, at the moment PolyWorks doesn't like mixing for the same feature touch probes and head touch probes. So the idea of that is you have to make sure you do a plane manually and then head touch the circle. It doesn't like doing, and especially when we have to probe at a slight angle with the RSP2 head. The RSP2 probes are designed to bend to take a signal. You don't really want to poke straight down normal to it, otherwise you're not truly bending it in a controlled fashion to get an accurate measurement. So ideally probe the plane separately, and then we'll use that constraining plane. So let's set that to use a plane feature, and I'll select this plane. That is our plane 5. Again, we can specify the point spacing, coverage, how deep, and so forth, much like you would with a typical CNC CMM connection. These 2 circles at the end here, we'll just do a standard head touch for these. So again, we'll set that to probe a local plane, and I'll pick this plane here, which is our plane 2, and we'll probe 4 points on the inside there. That's our program pretty much written up. We've told PolyWorks for the most part how we want to measure in terms of where the points are, how many points and so forth. But now we need to then start to build this up while applying the 5-axis or 3-axis head touch components. So I'm going to start by getting the probe into a nice orientation first. So one thing that is now built in natively into PolyWorks is the ability to do a go-to position while enabling a tool orientation change. So you can do an actual 5-axis go-to position natively within PolyWorks. So if I tell PolyWorks to, let's just double check. Remember where PolyWorks starts. So we'll start on the far side there. So what I can do is go ahead and tell PolyWorks to go to position. to the far side while applying an angle. If I know the angle, I can type the angle in. If I don't know the angle, I can also pick it, or I can adjust the jog box to the angle that I want and then get PolyWorks to record the angle if I wanted to. What's also new to 2025 is the ability to visualize your tool orientation that you're picking. So rather than just getting a digital visualization of the orientation, you get to see the actual arm, the quill with the probe head as well, using the toolbars along the bottom. So if I turn that off, you can see there the probe returns back to its current position, and I'm left with just the digital orientation picker. But with this button turned on to show the CMM component, it shows me the orientation of the actual probe head as well. Not only that, we also have the ability to pick our angle and then use the mouse wheel to scroll to increase an angle. So the idea is, as I mentioned, ideally we don't want to be probing normal to a flat surface. We want to apply an angle to that. So the idea is, once you pick this orientation, which gives you the normal, we can then scroll a mouse wheel to apply a slight angle to it to help improve the accuracy of the probe. But that only adjusts by small amounts. What I'm going to do instead is I'm actually going to be clever about this and actually pick at an angle off the edge of the part, which will give me the angle that I need. So that is my 30 minus 90, or 35 minus 90. And then you can right click to confirm, and we have that 30 minus 90, or 92 in this case. Okay, so what I can do now is, if I hit record, hit go to, let's just see what areas we have there. So we're missing the tool orientation. That's because we're in a slightly different orientation at the moment. That's fine, we're going to apply a new one anyway. So let's go, and it should then go to position while changing the tool orientation. So compared to when I write programs with a CNC CMM connection, often I can write a full program completely offline and then run the program at the end. With the Revo, I personally like to build it up bit by bit and actually run it live on the machine. I can preempt a couple of movements, but I always like to, at certain points, run it to see where I ultimately end up. Especially with all the extra head movements that the head can perform, you're not always too sure where the head will end up or what orientation will end up at the end of a measurement. So I like to build it up slowly and actually see where I end up before planning the next step. So now that I have that step in, if I highlight my first plane that I wish to measure, I can go ahead and jump into this I++ multi-axis ribbon that pops up. And then I can specify I'm applying a multi-axis head movement to my features. And I can specify whether I'm doing a 3-axis head touch, a 5-axis head touch, or I can keep the head, the probe head, along whole axis. Obviously that doesn't apply to planes here, so we can ignore that one, and I'll come back to that one later on. In this case, I want to stick with a 3-axis head touch. I don't want the head to be potentially rotating around and swinging across, because we're going to have to avoid this area to go around to the opposite side. So I'm happy to maintain this orientation while using maybe the just the A angle to take a point with. So we'll tick that on. We don't want to swing the probe normal to the hole. Again, this doesn't apply because it's not a hole, but I will insert it into my sequence. So if I tick the last option, click OK, it should add it to our sequence. Just be mindful of if there's an existing step highlighted, it'll assume that you wish to stick this above that step. So make sure you have nothing highlighted within your sequence, so it ends up adding it to the end. If you make that mistake, not a problem, just drag and drop it to where you need it. Once we get to the opposite side, the next thing I probably want to do is maybe another go-to command to make it normal to the hole, so then I can probe the cylinders. So rather than using the go-to command from the ribbon along the top, I can just right-click within the sequence, insert. I want to insert a go-to position, and you can see here I can pick my go-to position, which I'll send across to the part there. But I'll also tick on the tool changer, and then I'll pick a normal orientation to the cylinder that I'm trying to measure. So click once, and then I can right-click to confirm. There you go, sorry. So However, before I do any of that, I also need to do one more step as well. Currently, because we're running macros to do the 5-axis head movements, we can't do them with a custom coordinate system. So because I originally created an additional coordinate system to help compensate for the angle of the part, now that we're pre-aligned, we don't actually need that anymore, and I can revert back to my original world coordinate system. So if I right click on the world, reactivate that, and because I'm still recording, it's added into my sequence. So this will go off, measure that first plane, measure the, go to a new position while adding a tool orientation. We'll then start to measure our next couple of features. So our 2 cylinders will actually go into our features for the multi-axis ribbon. We'll do a 5-axis head movement here. Again, the key probe head along whole axis doesn't apply to this. Even though it has an axis, this is actually technically an external feature rather than an internal feature, so technically not a hole, so it doesn't apply. Insert that into our sequence. Okay, that, and you can see it adds those to our sequence there as well. At this point, I'm going to run it and see what happens, see where we end up. Not only that, but we need to measure these 3 features first before we then do a final alignment to make sure everything's in the right location before we then continue measuring the rest of our part. And we can do that by creating a circle from our plane and the 2 cylinders. So I'm going to highlight my 2 cylinders and my plane, create 2 circles. So from intersection, from plane and cylinders, and I'll call these circles, not in capitals, alignment circles. Okay, so I'm going to hit run, and it should hopefully measure those 3 features. Okay, so now that we have those 3 features measured, our 2 alignment circles have also measured. So the next step is I'm going to hit record and then perform our final alignment. So we'll do a plane axis center point alignment in this case. We'll align to plane 1 measured to plane 1 nominal, alignment circle measured to alignment circle nominal, and alignment circle 2 measured to alignment circle nominal. Align, and you can see that's added to our sequence, and everything should now hopefully be in the right position. So now we can go continue measuring everything else. Everything hopefully should be in a better position compared to what we were before. Next up, let's measure our side plane here. Before we do that, let's add in a slight tool orientation change and maybe go to again. So then if I go to my devices, go to position, I'll add in a go to position a little bit further out. And I'll add in a tool orientation where I'll have a slight angle. Go to, see where we end up. Should be good. And then we can now highlight our plane. So this is our plane 2. We can add our head touch command to it. This one, we can do a 5-axis head touch. We don't need a 3-axis, so we can use all 5 axes rather than just doing a single linear head touch. We can now move the head a lot more, potentially stretch the head to a further range. And again, we'll insert this into our sequence. But you'll notice if I insert it now, it doesn't appear at the bottom, it appears above our selected previous step. Not a problem. Again, I can drag it to the bottom. So to prevent that from happening, ideally I should have made sure that nothing was selected within our sequence. Once we do that, we can then move on to our 2 circles. So our 2 circles are 3 and 4. Now these 2, I can actually apply my 5-axis head touch, but this time I can use the key probe head along whole axis, and I can tell it to use the orientate along whole axis. What that does is it gives us a free go-to and tool orientation change to get it normal to the hole, rather than me having to manually insert that myself. And again, let's insert that into our sequence. And we probably want to drag that down below our step. With those 2 added, I can preempt the next couple of steps as well. So I'm going to right-click and insert a go-to position. We'll send the probe further out, while also applying a tool orientation change. and that should allow us to probe this plane on top. So if I select that plane there, again, apply my 5-axis the multi-axis head touch. As well as that, I'll also include maybe plane 4 as well. So with those two selected, we'll do a 3-axis. We'll insert them into our toolbar, into our sequence. Once we finish probing that plane, those two planes, we'll probe the slot here as well. So hopefully once we finish probing that plane, we can do the slot straight away. I'll add in another tool orientation and go to. So we'll retract further up and we'll change the orientation so it's normal to the surface. And then we'll add in our slot. I didn't actually create the slot, so let's create the slot. If I just quickly jump into the properties, tell PolyWorks we wish to CNC probe this. Probing the top edge, we'll constrain it to our plane 4 on top, and we'll probe 4 points rather than 3 points per arc. Apply, close. Now I'll apply the 5-axis to that. Again, because it's not a hole, it's an external feature, the keep probe head along hole axis and orientate tool along hole axis doesn't apply to this, so we'll just treat it as a 5-axis. Okay, so once we finish that, let's then see where we end up. So let's hit the run. So again, we don't have a sequence step for that movement there. That was part of the actual macro for the head touch for internal hole features. Okay. While we're up here, let's also finish off the rest of the features on top, where we've got these 6 comparison points on the top surface there. So we do actually have a head touch macro for comparison points specifically. So if I go to my tree, highlight my comparison points, we can add those to our sequence using the head touch macro. Before we do that though, let's quickly apply an angle to this. And maybe another go-to command. So I'm going to hit record again, go back to my device, go to position. So let's just, we'll probably leave it in the same position. Actually, let's move it a little bit closer. Then apply an angle more suitable for probing those comparison points. So go. So with those comparison points highlighted, we can go into our I++ multi-axis toolbar, and we can then jump into our comparison point head touch macro. Those comparison points are selected. We can do these in either a 5 or 3-axis head movement. We can optimize the sequence by putting them into a macro, and we can also insert them into our sequence. So let's do all that. And you can see there, PolyWorks has created a little mini macro to go ahead and probe these comparison points. The only purpose of this is just to speed up the time it takes to do this. The macro will send the commands one after another quickly, and it will measure 1 point after another, versus if you were to just insert them in as separate comparison points, there's a second difference between probing the first one and then sending the commands and then updating it, going to the next one, go to the next comparison point, probing that, updating it, and so forth. So in this case, the macro runs first and then everything updates afterwards. Just saves you a little bit of time in the long run. So if I hit run, let's see where we end up. And because there's no before and after clearance, we've actually saves a lot of time having to travel back up and back down again, especially when there's no obstructions. All the points are pretty much on the same level. We can get rid of that clearance. The remaining features that we need to measure are all on this end and the far side. So let's go ahead and measure the plane on this surface here maybe. And again, before we do that, let's again do a go-to movement. So let's go to position. Let's move it away from the part while applying a tool orientation suitable for the plane. If you weren't happy with that movement within our sequence, you can see here we can still modify and change that. So maybe we'll change the B angle a little bit more. Let's say 180. And then we can get PolyWorks to just run that step again. It's better. So let's go and highlight our plane. Again, apply our head touch macro to this. We'll do a 5-axis head touch, insert it into our script. Okay that, and again, just drag that to the bottom. Once we finish probing that, we can then return back to normal and then start probing these holes. So in this case, let's do cylinder 5. Let's double check. So cylinder 5, we're going to tactile scan, whereas cylinder 6 will apply a helical scan. Because we're not doing the head touch, we don't have that orientate to the axis of the hole, so we'll have to do it ourselves. So again, start recording, do another go-to command, off the surface, normal to the surface, and then go. Let's go back to where we were, sorry. We haven't measured that plane yet. So rather than running the go-to like I did before, I should have just right-clicked and inserted the go-to instead. Let's add in our cylinders. So those two I can just drag in because they're all set up, ready to go anyway. And then we have our circle 1, circle 2. They're tactile scanned, so again I'll just add those in. Because of the clearance, the probe will automatically retract further out anyway, go across and then in, so there's no need for adding any go-to commands. If you're worried that the probe won't be pointing normal to the hole though, we may need to insert an actual tool orientation change to get the probe back normal to the hole. But let's run that and see what happens. Besides the ability to do a helical scan when tactile scanning cylinders, we do also have a macro that allows us to tactile scan a circle with a head touch, with a head tilt, sorry. So you can actually specify an angle to maintain while it tilts and scans around. We also have a macro that allows us to do a 5-axis head sweep across the surface, as well as a multi-axis tactile scan around a cross-section. So with this circle, we're actually tactile scanning 3 individual circles. This is using a built-in native tactile scanning option. Whereas the next cylinder here, we're going to do the helical scan, which as I mentioned, we're using a macro for. And again, these 2 circles are tactile scanned, again, using the built-in native tactile scan functionality. So this would be the same if you're using an SP25 on a PH10 head. Now that side is complete. The only two things left are the two cylinders at the end there. So like we did before, we'll hit record, go to, send it to the end, while applying a tool orientation change to be normal to the surface. Okay. And then our two cylinders, they're going to be head touched using 5-axis, so we can go into our I++ multi-axis tool, apply our 5-axis head movement, insert our sequence, probably rearrange those to make it more optimal, and then just run it. And that's everything measured that we've created. Now, I'll add in two bonus items to this. I'll show you the sweeping macro, and I'll show you the cross-section tactile scan option as well. So what we'll do is we'll sweep along this partial cylinder. To do that, all we need to do is go ahead and create a polyline. I'm going to create a polyline by anchoring a straight path. So we'll pick a start point, an end point, and then with that polyline, I can jump into my Advanced CMM toolbar, go to your tactile scanning option, and you can see there we have the option of performing a 5-axis sweep scan. All you need to do is specify the point-to-point spacing, the wavelength, so kind of how often it changes transitions or changes direction, similar to like a pitch on a thread if you like, and then your width, how wide of the area do you want to cover. So we'll have a wavelength of about 5 mil. We'll have a width of about 15 mil. You do need to specify whether the surface you're probing or scanning, sorry, is convex or concaved. In this case, it's convexed, and we need to give it a rough height. It doesn't need to be perfect. We just need to give it enough range for it to follow. So in this case, it's roughly about 8 mil. Should be fine. Okay, that. And before I perform that, let's send it to a more suitable location. So again, we'll add in a go-to command and the tool orientation change just above our surface. And I'm going to apply an angle to this. So besides rather than being normal to it, we'll apply a bit of a leading angle to it. That may not work. So what I'm also going to do is just quickly move the head up, record that position, then go to my new location. Okay, and now I can drag and drop my polyline into my sequence and ask PolyWorks to go ahead and measure it. And with those points on that surface, we can then obviously create either a cylinder or a surface feature, extract all those data points to help measure the area. To show you the 5-axis cross-sectional sweep scan, we can create a cross-section first. So if I create a cross-section, create it along the y-axis, maybe we'll go around the slot. Let's just resize that so we're only capturing data around the slot only. It's not the end of the world if you don't do this. It just makes it a little bit tidier for me. And then what I need to do is create a polyline for the REVO head to follow around. So if I go ahead and create a polyline, but I need to do it in a specific way. So I need to pick on CAD, and I need to make sure that the polyline I'm creating is tied to the cross-section. And we do that by ticking on the on cross-section option, picking on the outline to create the polyline, and then close. And now with that polyline, we can go ahead and jump into our Advanced CMM toolbar again, go into our tactile scan option, and we can apply a 5-axis cross-sectional scan. Again, specify the point-to-point spacing, i.e. the 1 point per 1 millimeter, the head tilt angle, and we also want a head advanced angle. So obviously from your normal surface, from that surface, you're telling it what angle to apply from the normal, and then an advanced kind of trailing angle that it will drag along. So in this case, I'll put 30 degrees for both maybe. Because this is a closed polyline, we can actually give it a starting point. If it's an open polyline, it'll start from one end, travel to the other. But because it's a closed polyline, we can give it our own start point if we wanted to. So I'm going to do that in this case. And I can also specify whether I'm actually measuring the polyline itself or the cross-section that I originally created off. So we'll actually measure the cross-section. Okay, that. And then it'll ask me to pick where I want the cross-section, the polyline to start. I'll start on one of the flat spots maybe. Right-click to confirm. And then now that's ready, I can drag that into my sequence and then hit run. I do get a warning, but you can ignore that warning for the time being. That generates the probe surface once we get it going. So hit start or hit the running man to run. And the macro should then take over. Calculate the polyline points it requires, all the orientations that it needs to follow, and then sweep around. And that's how we complete an inspection using a REVO head. So now they have the program complete, you can obviously finish this off and tidy up by potentially moving the probe into a safer location, resetting the tool orientation, ready for you to potentially take the part off, drop the next part on, and then we can then run it as a new piece, and everything will then fully run through the program as it would. If you wanted to as well, obviously we can then up the speed. A lot of the speed is controlled within the UCC server itself. PolyWorks can adjust some of the speeds, but there are some that PolyWorks can't, so you'd have to actually do it yourself within UCC, and then you can obviously do the head touch movements a lot more quickly, the tactile scanning a lot more quickly, but again, all that can be controlled within the UCC side. Thank you for joining us in today's video. Hope you learned a lot regarding the integration of the REVO head within PolyWorks. If you need any more tips, PolyWorks tips and tricks, please visit our YouTube channel. If you've got any suggestions on future videos, please comment in the section below. And please subscribe for future videos and updates. Thank you.